Hello guys, today we are going to use Gephi. Gephi is a tool to analyze and visualize real networks. We're going to use Gephi 8.2. The latest version of Gephi on the market is 9.0. So on Gephi we're going to open new project. Don't save. So open. We have like 7 type of data sets. I'm going to use second one, dolphin networks. As we know, we have 2 types of graphs. We're going to use undirected graph, new graph, hit OK. After that, we're going to this is Gephi, so we're going to use a layout. The layout is French marine gold in here. Hit run. We seeing movement in here. Until the movement stop, we can hit stop in here. Then go to preview. On preview there is some preference. For example, the border weight by default is 1. We can make it 2.0. We can come here to thickness, and the thickness by default is also 1. We can make it 2.0. Every time on Gephi, if you do any change, you have to click on refresh. So go to preview. On preview, right now we are going to do some statistics to calculate. First one, data average. Hit on run. It will give you degree distribution. The second one is network diameter. Network diameter in here. Hit run. Undirected graph. Okay. Close. After that, we're going to hit on modularity. On modularity, it is going to give you the community detection. Hit on run in here. Okay. Close. After modularity, going to connected components. Hit on run. Okay. Close. After that, go to hit average clustering. Run. Undirected graph. Okay. And then average eigenvector centrality. Undirected graph. Hit OK. And then close. So we calculate all the statistics we want, and as I said, we have 3 important icons on Gephi: overview, data laboratory, and preview. If you go to data laboratory right now, you can see the nodes, the ID, the label, degree, the sensitivity, closeness, betweenness, modularity, components. So everything we did on statistics you will see. And don't forget, every time hit or refresh, give you the update. So right now we're going to do important things, is to export data from, and make sure this is space in here. Separator should be space, and we're going to export this data to Excel to do the degree distribution. So this is why we're going to pick the degree and ID. That's it. So we don't need anything else. So I'm going to unmark all these: the closeness, betweenness, modularity, component, clustering, and number of triangle, and hit OK. And name it the name you want, and it will be .csv. Just save it as 2.csv.com, to the CSV. You will see message table exported successfully, and then open Excel. When you open Excel, go to open, and on the direction you save this file, you will find it. I saved on network science assignment 2 and zip file, and you have to make this CSV because we save it as CSV file. So go to text CSV file, then you will see 2 in here. Click open, hit the first column, select first column and go to data, text to column, text to column. On text to column, you have to make this space, next, and then finish. You will get the ID and degree. Then we can select all these, and sort. Go to sort by degree. Hit OK. As we see, they sorted by degree. We have degree 1 and degree 1. We can do it right here. This is degree, and this is the counts for each degree. We have degree 1, degree 2, degree 3, degree 4, 5, and so on. Now we will come here to count. Degree 1, it has count, as you see here, count 9. You write 9. Degree 2, it has count here 6. Put 6. Degree 3, it has count of 6. You put 6 and 3, and so on until the last one. We have degree 10 has count 2, degree 11 has count 2, degree 12 it has count 2. So after we did all that, we can go to, just I want to show you the final. Go to unzip file, so it will be like this one. Save. So like this one, we have node from 1 to 12. This is the count for each one, and then we can add them, sum all this count, it will give you 62, and then we can find the probability for each degree. For example, the sum is 62 and we have count 9, and as we know, the probability is event divided by sample space, so it should be 9 divided by 62. It will give you this value, and we can do for all degree. Then we come here to graph this one. We have the degree and we have the probability, so just name this degree and name this probability of K, and just select all and go to set and choose scatter XY, and it will give you the graph. Also, this is the graph we want, which is the degree distribution. We have on x-axis we have degree, on y-axis we have the probability, and that's it. This is for the first one. We come back to Gephi. On Gephi, now we're trying to find the correlation between different metrics. For example, the correlation between node degree and local clustering, the correlation between closeness centrality and betweenness centrality, the correlation between different matrix. So all they are the same. All we have to know is we have color here, we have size or weight, and this is the matrix, the rank of parameter. For example, if we want the correlation between betweenness centrality, we hit on color and betweenness centrality and apply. We want to correlation with, so we go to size and choose the other one, which is closeness centrality, for example. Hit apply and then go to preview, and preview you have to hit refresh to see the difference. Will come here, hit refresh, this is the difference. So this is the correlation between the two we picked here, which is the betweenness centrality and closeness centrality. The same way we can find the trade-off or correlation between any of two matrices. Just hit color and choose the matrix, for example degree, hit on size, and on matrix find, for example, the efficiency, apply. Don't forget the same step, go to overview, hit refresh, you will see the difference in here. That's it. So final, I can add, if you want to find the path length, just hit here on path length and directed graph. Okay, it will give you the radius, the average path length, which is 3.3, as you see in here. This is for everything. Thank you for watching. See you next time.